Okay, so now we're going to work on actually making the chemical formulas based on the atoms that they contain. Okay, so first we have lithium and fluorine. Okay, so somehow I need to combine these two in a way to make a compound which is called lithium fluoride. The thing that I really need to pay attention to is what are the charges. So in this case, lithium is an alkali metal, so it normally has a charge of +1, or that's the charge that we assign it to based on its location in the periodic table. It's in the first column, so it will tend to lose an electron, hence the +1, when it forms a compound with fluorine. Fluorine, on the other hand, is very happy to gain that extra electron. So we say that it has a charge of -1 based on its location in the periodic table. If we want to create a neutral compound, we want to make sure the charges cancel out, right? Well, in this case, I guess our job is sort of done. So if lithium is +1 and fluorine is -1, then we don't need to change any of the subscripts because the +1 and the -1 already cancel out. So in this case, we have an ionic compound, and what's happening is lithium is giving its one extra electron to fluorine, and it works out very nicely. So not much to do there. So kind of a boring example. We'll do the next one. The next one is sodium plus oxygen. Okay? Sodium is also an alkali metal right below lithium. So likewise, it also has a +1. Oxygen, on the other hand, is not below fluorine, but it's in the column over from that. It doesn't like to take one electron. It likes to take 2 extra electrons in order to make a compound. So we say that it likes to have a -2 charge, right? Okay, so if we want to make our compound sodium oxide, I need to now consider what my subscripts will be. Up here, I had +1 and -1, so they kind of canceled out. Here, though, if I have a +1 here and a -2 here, they're not going to cancel. I'm still going to have an overall charge of a -1, unless I add my subscript here. It might not seem to be an intuitive thing to do at first, and in fact, a lot of students will write NaO2 the first time, but this is incorrect because, as you can tell, you will have +1 times only one sodium atom, giving you an overall +1, and a -2 times 2 oxygen atoms, giving you a -4, and that's not a good thing. So that is very, very bad. Okay, so if you're ever confused, I mean, you can just do the math and you'll see. So I have +1, but I have 2 of them, so it gives me an overall +2 with regard to my sodium. And I have only one oxygen, and it is -2, so I have an overall of -2 with regard to my oxygen. +2, -2, they cancel out, so we're happy. Okay? Seriously, I can't emphasize enough. Do the math and you'll see, because otherwise you'll make silly mistakes. Okay? So let's double check to see if we understand then. In the next one, I have aluminum and oxygen, and I want to combine them, of course, to make some kind of aluminum oxide. Aluminum's on the other side of the periodic table compared to lithium and sodium, but it's still considered a metal. And in fact, it likes to lose 3 electrons because it's in the third column after, the transition metals. And like we said before, oxygen is -2. So aluminum is +3 and oxygen is -2. Okay? Oxygen wants to gain 2 electrons. Aluminum would happily give up 3 electrons in order to be a compound. So if I have a +3 here and a -2 here, what do my subscripts need to be? Well, I can bet that one of them is going to be 2 and one of them is going to be 3. And if I want the whole thing to be neutral, I got to make sure that they cancel out correctly. So what you do is you cross them. So this, I have a 2 here, I want to put a 2 here. I have a 3 here, I want to put a 3 here. But let's double check. +3, and there's 2 of them, which gives me a +6. -2, and there's 3 of them, gives me a -6. So you always want to stick within one element and then check the other element and make sure they cancel. In this case, they do. So Al2O3 is my compound. Okay. And let's try one more, just to be safe. Always good to reinforce these ideas. Magnesium and bromine. Okay. Bromine is in the same column as fluorine. All right, it's a noble gas. It's a halogen. It is not a noble gas. Bromine is a halogen, and so like fluorine, it's got this -1 that it likes to take on. And magnesium is right next to sodium, and it has a +2 charge instead. Okay? So this case is kind of similar to this one, except reverse. The metal has the 2, and the non-metal has the 1. So what do you think we should do? First step is always to just write out MgBr. Now, if this has a -1 and this has a +2, remember I kind of want to cross to see what they're going to be. I don't need to write my 1 here, it's just implied, but I will write my 2 here and double check. I have 1 magnesium with a +2, which gives me an overall +2, and I have 2 bromines, each with a -1, which give me overall -2, +2, -2. It all works out, and we're happy. Okay, so you don't even need to be given the subscripts in many cases, with the exception of transition metals and all, but for anything in the first column, second column, etc., all the way up through the halogens, again, minus transition metals, you know what charge they want to become. Aluminum always wants to take on a +3. Oxygen always wants to take on a -2. And we'll learn more about why that is later on. But when it comes to forming compounds, you just want to consider what they want to do with their electrons. Do they want to gain extra electrons, or do they want to lose extra electrons? Okay?